Alright, hi everybody, this is the Math 31 optimization review. This is question 4. This is a classic problem about the dimensions that would maximize the volume of a box. Maximize the volume of a box given a restriction on the surface area here. Now, it's an open top box, okay, with a square base. Okay, so I'm not entirely sure how far down this goes, but we know that the dimensions of the base will be x and x, and then the height will be y. Okay, so here's our open top box. We are going to try to maximize. We're going to try to maximize the volume here. Okay, so volume is going to end up being length times width times height, which in this case will be x squared y, and this is the thing that we want to maximize. So that's the thing we're going to take the derivative of. We are, however, given one other bit of information here. Okay, we are told that the surface area is 1200 centimeters squared. Now let's just think about what that's going to look like. It's an open top box, so there's no material here, but there is around the sides, and that's going to be xy. Okay, xy, and there will be 4 of those. So that's 4xy, and then the base here is simply going to be a single x squared. So here's the relationship between x and y here. Then I'm going to take this relationship and I'm going to find some way to plug it into this term right here. Now, looking at these, I suspect the easiest thing for me to do here to avoid. Now, normally I would have said, oh, jump right on that x squared right there. But that's going to give me an x and a y in there. It's not actually going to solve my problem. So what I'm going to do here is bring the x squared over and divide by 4x to get y. That's about the most direct substitution I'm going to get. That'll be all in terms of one variable. So now, therefore, volume, oh, I'm sorry, you can't see that at all. Volume is going to be equal to x squared y, which will be 1200 minus x squared all over 4x. Okay. Well, we'll multiply this out here, but one of the x's is going to cancel here. So this is going to end up being 1200x over 4. Okay, one of the x's cancel, but one of them distributes. That other x distributes over here, so this is going to be minus, that'll be minus x cubed all over 4 as well. So really what I'm doing here is I canceled one of the x's in the numerator here with that x in the denominator, and then I distributed the x and honestly distributed that division by 4. And so now the derivative of volume is going to be, well, 1200 over 4 is just going to be 300. And then the derivative of x is just 1. And then over here, this will be minus 3/4 x squared. Okay, I'm looking to determine the maximum here. So I'm going to set this equal to 0. Okay, so it'll be 300 is equal to 3/4 x squared. Okay, I'll divide by 3, multiply by 4 to get 400 equals x squared. And it turns out in this case that that's actually relatively easy to do. This is going to end up being 20, plus or minus 20. Okay, I probably should write that down there, plus or minus 20, but the truth is positive 20 is the only one that works, or that makes any sense here. Now, we should determine, though, whether or not that actually does give you a maximum here. So let's just take a quick look at the number line. The two numbers that I got popping out of there are negative 20 and 20, even though the negative 20 doesn't make any sense. I'm still going to take a quick look at what that does here. And let's just start picking some numbers here. If you pick a number, sorry, you got to look at the derivative here. If you take a number that's bigger than, let's say, 20, I don't know, like ridiculously larger than, let's make it like 1,000 here. 1,000 squared, okay, is going to be, you know, a million here, right? So, and 3/4 of a million is definitely bigger than 300. So 300 minus that. So if you pick a number here bigger than 20, this is decreasing. Sorry, negative. This is going to be decreasing. If you pick a number between negative 20 and 20, and now we're going to get lazy here. Let's pick like 0. If you plug 0 into this, you're going to get a positive. It'll be 300 minus 0. So this was positive, which means the original function was increasing here. Now, I don't really even need to care so much about this because all I really got to focus on is the 20, but I'm increasing to the before the 20, decreasing after. That actually does make it the maximum that I'm looking for, which is good. I needed to know that. So the largest volume of the box is, find the dimensions. So the dimensions will be x is going to equal 20 centimeters. And then if you come over here, now it's a little bit of a complicated expression here, okay, but that's okay. So 20 here, 1200 minus 20 squared, okay, well, 20 squared is 400, 1200 minus 400 is 800, and actually 4 times 20 is going to be 80, so 800 divided by 80 is just going to be 10. So y is equal to 10. And it says, what is the largest what is the largest volume of the box? Well, this is 10 centimeters. The volume is going to be, went too far, x squared y. So that's going to be 20 squared, 400 times 10. So the answer is 4,000 centimeters. Oops, can't see that, 4,000 centimeters cubed.